Good day everyone, I'm Kong Yan and today I'm going to present my AAW318 project. My project title is Customer Lifetime Value Prediction using Machine Learning. This study investigates how machine learning techniques can be applied to predict customer value in an e-commerce environment and how these predictions can support more effective customer relationship management and business decision making. With the rapid growth of e-commerce, businesses now collect large amounts of customer data through online transactions and interactions. In today's competitive market, retaining existing customers is often more cost-effective than acquiring new ones. Therefore, businesses are increasingly focusing on understanding customer behavior and identifying customers who contribute the most value to the organization. One important metric used for this purpose is Customer Lifetime Value, or CLV. CLV refers to the total value that a customer generates throughout their relationship with a business. By accurately predicting CLV, businesses can allocate resources more effectively, improve customer retention strategies, and maximize long-term profitability. Although CLV is widely recognized as an important business metric, many organizations still rely on traditional methods such as historical spending summaries and simple customer segmentation approaches. These methods mainly focus on past behavior and often assume that future customer behavior will remain unchanged. However, customer behavior in e-commerce environments is complex and constantly evolving. Traditional approaches may not be able to capture the relationships between customer demographics, purchasing behavior, engagement, and satisfaction. As a result, businesses may struggle to accurately identify high-value customers and make effective strategic decisions. Therefore, there is a need for more advanced predictive approaches such as machine learning to improve customer lifetime value prediction. This study was conducted based on four main objectives. The first objective was to analyze customer behavior using e-commerce customer data. The second objective was to develop machine learning models to predict customer lifetime value. The third objective was to compare the performance of different machine learning algorithms. And finally, the fourth objective was to segment customers into different value groups to support targeted marketing and customer management strategies. Next, this slide presents the overall methodology adopted in this study. The research began with data collection and pre-processing. This included data cleaning, handling missing values, and encoding categorical variables. Next, exploratory data analysis was conducted to better understand customer behavior and identify patterns within the dataset. After that, two machine learning models, linear regression and random forest regression, were developed and evaluated. Customer segmentation was then performed using k-means clustering into group customers with similar characteristics. Finally, the results were visualized using Power BI dashboards to provide meaningful business insights. The dataset used in this study consists of 350 customer records. It contains demographic, behavioral, and spending-related variables, including age, gender, membership type, items purchased, average rating, days since last purchase, satisfaction level, and total spend. These variables provide valuable information about customer characteristics and purchasing behavior, allowing machine learning models to identify factors that influence customer value. This dashboard provides an overall summary of the customer dataset. The dataset contains of 350 customers who generated approximately 295,880 ringgit in total revenue. On average, each customer spent 845 ringgit 38 cents and purchased about 13 items. The average customer rating was slightly above 4 out of 5, indicating generally positive customer experiences. One interesting observation from the dashboard is that Gold members contributed substantially higher spending compared to Silver and Bronze members. This suggests that membership level may play an important role in determining customer value. The customer behavior analysis revealed several important patterns. First, customers who purchased more items generally recorded higher total spending. Second, there was a negative relationship between days since last purchase and total spend. This indicates that customers who purchased more recently tended to spend more than inactive customers. In addition, customers with higher satisfaction ratings generally demonstrated stronger spending behavior. One important issue identified during the analysis was the strong relationship between item purchase and total spend. Since customers who buy more items naturally tend to spend more money, there is a possibility of data leakage if this variable is used directly in the prediction model. To address this concern, an additional validation model was developed later by removing the item purchase variable and comparing the results. To predict customer lifetime value, two machine learning models were developed: linear regression and random forest regression. Linear regression was selected as a baseline model, while random forest was chosen because it can capture more complex and non-linear relationships among variables. The results show that random forest significantly outperformed linear regression across all evaluation metrics. Linear regression achieved an R-squared score of approximately 0.95, while random forest achieved an R-squared score of 0.9994. In terms of prediction errors, random forest also recorded much lower MAE and RMSE values. To address the potential data leakage issue discussed earlier, the random forest model was retrained after removing the item's purchase variable. Even without this variable, the model still achieved an R-squared score of approximately 0.9974. This demonstrates that the model remained highly accurate and that its predictive performance was not solely dependent on the item purchase variable. Therefore, random forest was selected as best performing model for customer lifetime value prediction. Future importance analysis was conducted using the random forest model to identify the variables that contributed most significantly to customer lifetime value prediction. The results revealed that Gold membership was the most important predictor, accounting for approximately 74% of the total importance score. This can be explained by the spending patterns observed in the dataset. Gold members consistently recorded significantly higher spending compared to silver and bronze members, making membership status a strong indicator of customer value and loyalty. Besides membership status, average rating and item purchase were also identified as important predictors. These findings suggest that customer satisfaction, loyalty, and engagement play important roles in determining long-term customer value. After predicting customer value, K-means clustering was applied to segment customers into groups with similar behavioral characteristics. The analysis identified three customer segments: high-value, medium-value, and low-value customers. High-value customers recorded the highest average spending, purchased most items, and reported the highest satisfaction levels. Medium-value customers demonstrated moderate spending behavior and represent a strong opportunity for future growth. Low-value customers recorded the lowest spending levels and the longest period of inactivity, indicating a higher risk of customer churn. These segmentation results provide businesses with useful insights for developing more personalized marketing and retention strategies. Based on the findings of these studies, several recommendations are proposed. First, businesses should strengthen their loyalty programs and encourage customers to progress from bronze and silver membership levels to gold membership. Second, businesses should continue improving customer satisfaction through better customer service and post-purchase experiences as satisfaction was found to be an important predictor of customer value. Third, customer reactivation campaigns should be implemented to re-engage inactive customers before they permanently stop purchasing. Finally, marketing efforts should focus on medium-value customers because they represent the segment with the highest potential to become high-value customers. Implementing these strategies can help businesses to improve customer retention and increase long-term profitability. To conclude, this study successfully achieved all four research objectives. The study analyzed customer behavior, developed machine learning models for customer lifetime value prediction, compared model performance, and segmented customers into meaningful value groups. Among the models tested, random forest demonstrated the highest predictive accuracy and significantly outperformed linear regression. The findings revealed that membership status, customer satisfaction, and customer engagement are the important factors influencing customer value. In addition, Customer segmentation provided actionable insights that can support targeted marketing and customer relationship management strategies. Overall, this study demonstrated that machine learning is an effective and practical approach for predicting customer lifetime value in e-commerce environments and can support more informed, data-driven business decisions. Thank you for your attention, and that's all from me today. Thank you.